When we think about artificial intelligence, I feel like we almost always picture it as something, well, contained, like it's trapped behind a piece of glass, right?
Yeah, exactly. Behind a screen.
Right. It's the chatbot helping you draft an email, or the algorithm recommending what movie you should watch next, or maybe just code generating an image on your laptop. It's this purely digital entity, and it lives firmly inside our devices.
And, that feels safe. It feels safe because it is restricted to that digital environment.
Oh.
I mean, as long as you have the power to just close your laptop or turn off your monitor or put your phone back in your pocket, you have the comfort of knowing you can simply walk away from it.
You literally hold the off switch.
Exactly. The physical world remains yours.
But so, what happens when that boundary completely disappears? Imagine a scenario where the AI isn't just some app you can uninstall. Instead, it's like bolted to the streetlight.
Right out in the open.
Yeah. It is sitting at the intersections you drive through every single day, quietly processing the physical world in real time. Suddenly, that off switch is totally gone. You can't just close the lid on your commute.
No, you can't.
And to be clear to everyone listening, that isn't some dystopian sci-fi pitch. That exact physical reality is the center of a massive debate we're diving into today. This was all sparked by an incredibly dense excerpt from an AI News Daily Digest from August 18th, 2026.
Yeah, specifically referencing a pretty major piece from Technology Review titled, What Flux Defenders Are Missing.
Exactly. Okay, let's unpack this. Our mission today is to explore this massive, real-world collision between artificial intelligence, physical surveillance, and really ethical responsibility.
Yeah.
So to understand the stakes here, we need to talk about the scale of what this company, Flock, has actually built.
Right, so to really grasp the scale, you have to look at the whole landscape of police tech. Flock is a dominant force in this space right now.
Yeah.
And their primary footprint in the real world comes in the form of automatic license plate readers.
ALPRs, right?
Yeah. Yeah, ALPRs. But, these aren't the bulky, flashing cameras you might remember from like a decade ago. Flock operates a sprawling, highly interconnected network of approximately 120,000 of these AI-powered readers scattered across the United States.
120,000. I mean, that is a number so huge it almost just washes over you. So for you listening right now, let's try to ground that. Think about a traditional toll booth. You drive up, a camera snaps a picture of your license plate, and it registers that your car was at that specific location just to charge you $1.
Classic simple transaction.
Right. Now, take that toll booth, make it completely invisible, and decentralize it. Place those invisible checkpoints at 120,000 different points across the country. But instead of collecting quarters, this system is passively collecting data points on the movement of vehicles.
Which fundamentally means the movement of people.
Exactly, on a national scale.
What's fascinating here is the mechanism behind that collection. It illustrates this huge transition from just passive photography to active machine vision. Older cameras, they literally just took a JPEG of a car passing by and dumped it into a massive unorganized server.
Just a giant hard drive of photos.
Yeah, it was dumb storage.
Yeah.
But Flock's cameras are essentially computers on a pole. They don't just take a picture. The AI instantly analyzes the image right there on the spot.
Wow.
It identifies the characters on the license plate, the make and model of the car, the color, and even distinct features, like a roof rack or a bumper sticker. It translates all those visual pixels into a highly searchable text string in milliseconds.
Wait, really? So it's not actually a giant database of photographs. It's more like a searchable text index of the physical world.
That is exactly what it is.
So if law enforcement is looking for, say, a red pickup truck with a dented bumper, they don't have to scroll through thousands of photos. They just query the database like it's a search engine, and the AI instantly flags every single time a vehicle matching that exact description passed one of those 120,000 nodes.
That is the exact paradigm shift we're talking about. It's no longer about capturing an image. It's about querying physical reality.
Right.
We are taking the search capabilities that we totally expect from the internet and applying them to the physical movement of everyday citizens.
That is wild.
And because the AI handles the heavy lifting of categorizing the data instantly, the system is incredibly fast and, frankly, incredibly efficient.
Which completely changes the stakes of how we govern this technology. I mean, if a search algorithm on a website changes, maybe you get a different sponsored ad, right?
Sure, low stakes.
But when the underlying software for 120,000 physical tracking devices changes, it impacts the fundamental reality of how you navigate your town or your city. And that brings us to the recent catalyst for the controversy that the Technology Review piece highlighted. A network this massive didn't just stay static. The company recently pushed out major platform updates.
Yeah, and those updates had a twofold aim. The first goal was pretty standard for any tech company, which is to enhance the platform's functionality. They wanted to make the machine vision more accurate, reduce latency, and just improve the overall efficiency of the tool for law enforcement.
Makes sense for a product update.
But the second aim was far more complex. Flock stated that these updates were simultaneously designed to address growing public concerns regarding privacy and mass surveillance.
Okay, I have to challenge that logic because I know exactly what you listening are probably thinking right now.
Yeah.
If a company tells me they're making a surveillance camera better at watching me, but also somehow protecting my privacy more at the same time, that sounds like pure corporate doublespeak.
It does sound like an oxymoron.
Right, you can't just put lipstick on a mass surveillance network and call it a privacy tool. How do you actually make a tracking system more private while increasing its tracking functionality?
It sounds like an inherent contradiction, absolutely.
Yeah.
The way you attempt to solve that paradox is through the architecture of the software itself, specifically shifting how and where the data is actually processed.
Okay.
Let's look at the concept of edge computing. Instead of a camera beaming raw, high-resolution footage of your car, your face, and your passengers up to some centralized cloud where anyone with access could view it, the AI processing happens on the edge, meaning right there inside the camera on the street pole.
So the camera is actually doing the thinking locally.
Exactly.
Yeah.
The AI extracts the necessary data, like the license plate number or the vehicle type, turns it into an encrypted text hash, sends only that tiny string of text to the central database, and then immediately acts as a digital shredder for the original photograph.
Oh, wow.
By making the AI functionally smarter at the edge, they argue they are protecting privacy because the raw, invasive visual data never sits in a vulnerable server anywhere.
Okay, I see the logic there. If there's a data breach, hackers don't get photos of me driving my kids to school. They just get a bunch of encrypted alphanumeric hashes.
Right. Furthermore, enhancing the functionality actually reduces a very specific, real-world type of harm.
What kind of harm?
Well, if the AI is rudimentary, it might misread, say, a G for a C on a license plate. And in the context of police tech, a false positive isn't just a tiny glitch on a screen.
Oh, right, it's an actual police stop.
Exactly. It means an innocent person might get pulled over at gunpoint because the system mistakenly flagged their car as stolen. By updating the AI to be highly accurate, you drastically reduce false arrests. So the company argues that better surveillance functionality is, in fact, an ethical imperative.
That is a wild paradox to wrap your head around. Making the AI smarter makes the system more ethical on a micro level because fewer innocent people get stopped by the cops. But on a macro level, it makes the overall surveillance dragnet utterly inescapable.
Precisely.
A flawless tracking system is technically safer, but it feels infinitely more dystopian.
Which is precisely why these updates acted as a lightning rod. By attempting to engineer their way out of a privacy debate through software updates, they ignited intense scrutiny from across the spectrum. It forced experts to evaluate whether you can actually fix the ethical problems of physical surveillance with just better code.
Let's explore how the public and privacy advocates are reacting to this because the divide is fascinating. And just as a quick note for our listeners, we aren't taking a side here. We're just holding up a mirror to the debate.
Right.
You have two very distinct camps analyzing these updates. The defenders who think this is a blueprint for responsible tech, and the critics who see it as incredibly dangerous. Let's look at the defenders first.
Well, their argument is rooted in pure pragmatism. You cannot uninvent automatic license plate readers. Law enforcement agencies across the country already use them, and they are incredibly effective at solving major crimes, like Amber Alerts or identifying stolen vehicles.
The genie's out of the bottle.
Exactly. So in that reality, a company aggressively utilizing edge computing to shred raw photos and establishing strict data retention limits, say automatically deleting all data after 30 days, is a massive leap forward, especially compared to legacy systems that hoarded raw images forever.
So they view it as a necessary evolution. If the infrastructure is going to exist in our cities, let's at least build it with software that prioritizes data minimization.
From the defender's perspective, dismissing these technical updates as mere PR stunts ignores the very real engineering effort required to build privacy safeguards directly into the architecture of the AI. They see it as a model for how the private sector should govern itself when deploying powerful tools.
Here's where it gets really interesting. Because if they are literally putting a digital shredder on every street corner and auto-deleting data, why is the privacy camp still sounding the alarm?
Because the critics look past the encryption and the 30-day deletion windows, and they point to the structural reality of the network itself. Even if all you have is an encrypted hash of a license plate, if you have 120,000 nodes collecting those hashes, you have built a centralized map of human movement.
That makes a lot of sense.
Critics argue that anonymized spatial data totally ceases to be anonymous when it's tracked over time.
Wait, I can see that. I mean, if a specific encrypted hash is logged outside my suburban house every night at 8 p.m., and then logged in the parking garage of a specific office building every morning at 9 a.m., and logged at a specific elementary school at 3 p.m.
They don't need your name.
Right. It doesn't matter that my name isn't attached to the hash, the pattern is me. Anyone looking at that data can easily deduce exactly who I am.
And that is the absolute core of the skeptic's fear. The updates might prevent a hacker from seeing a literal photo of your face, but they do not eliminate the existence of the honeypot itself. A centralized database detailing the daily routines of millions of citizens is inherently dangerous, regardless of the password protection or encryption layers you put on top of it.
It's just too much concentrated power.
Exactly. Critics worry heavily about mission creep. Today, the system is used to find stolen cars. Tomorrow, could it be used by a different administration to track who visits a specific medical clinic or who attends a political rally?
You know, when you look at the fundamental arguments of both the critics and the defenders here, they aren't actually disagreeing on the power of the technology.
How do you view the overlap there?
Well, neither side is acting like this is just a network of harmless traffic cameras. The defenders are saying this network is incredibly powerful, which is why we spent millions engineering edge computing safeguards. And the critics are saying this network is incredibly powerful, which is exactly why edge computing safeguards aren't enough to mitigate the structural risks.
That's a great point.
The tension isn't about the hardware at all. The tension is entirely about whether software can successfully govern physical reality.
That observation really strikes at the heart of the debate highlighted by Technology Review. If you deploy an infrastructure of 120,000 cameras, the margin for error in your governance is basically zero.
Right.
A single algorithmic bias, a single data retention glitch, or even a single policy shift immediately impacts millions of people in the physical world. The critics believe that risk is simply too high to be left to corporate self-regulation.
While defenders argue that iterative software updates are the only practical way to improve a system that society already relies on, this brings up an issue much larger than just one company, doesn't it? The debate over Flock's cameras is really just a localized flashpoint for a universal dilemma.
It really is. If we connect this to the bigger picture, this scenario is a real-time case study for the integration of all physical AI. It illustrates a deep friction between agile software development and rigid physical infrastructure.
How so?
Well, the software industry has spent the last 2 decades operating on the ship it and patch it model. You release an app, you wait for users to find the bugs, and then you send out an update to fix it.
But you can't apply the ship and patch it model to mass surveillance. I mean, if a photo sharing app has a bug, it just crashes your phone. If a decentralized physical AI network has a bug or governance failure, it alters real lives.
Absolutely.
It results in unjust police interactions, or it compromises the location data of millions of people.
And that's the danger. Technological advancement in the physical world is wildly outpacing our societal frameworks. The engineers are building the tools and bolting them to the streetlights much faster than lawmakers or citizens can agree on the rules for how they should even be used. We are essentially beta testing the governance of physical AI on our own public streets.
So what does this all mean for you listening right now? Why should you actually care about the nuanced debate over edge computing in license plate readers? Because, it's incredibly easy to write this off as a theoretical argument for tech executives and privacy lawyers in a boardroom somewhere. It feels detached from your daily life.
But it is the exact opposite of detached. The rules of the physical world are increasingly being dictated by the software running it. Every single time you drive to the grocery store or every time you take your kids to school, you are actively interacting with this infrastructure.
We are in the middle of an active, real-time dialogue about how to balance the obvious benefits of innovation with the protection of fundamental human rights. And right now, we just don't have a universally agreed-upon framework.
No, we don't.
We are relying on individual companies to balance functionality with privacy through these complex algorithms. The polarized reaction to Flock shows just how incredibly hard that balance is to strike, and how deeply people care when that balance feels off.
It forces us to ask whether our traditional legal and ethical frameworks which move incredibly slowly, can ever hope to keep pace with AI systems that can be fundamentally altered overnight with a simple platform update.
Let's briefly retrace the path we just took through this complex landscape. We started by looking at the sheer scale of the shift, right? Moving from localized, dumb traffic cameras to a national network of 120,000 nodes capable of converting physical movement into highly searchable, real-time text data.
And then we explored the paradox of the software updates. We unpacked how utilizing edge computing to make the AI smarter and faster at processing data was simultaneously touted as a necessary privacy measure.
Right. Creating a system that shreds raw data while drastically reducing the risk of false positives. And we looked at how that paradox totally splits public opinion. Defenders champion these updates as a pragmatic, vital step toward ethical AI deployment in tools that already exist.
While critics warn that building a highly efficient tracking honeypot is inherently dangerous,
Right.
regardless of how well the data is encrypted or minimized.
Exactly. And we zoomed out to the fundamental friction, the collision between the tech industry's rapid ship and patch methodology and the high-stakes reality of deploying mass surveillance in the physical world before society has agreed on the rules of engagement.
It all comes back to the thought we started with, doesn't it?
Yeah.
Artificial intelligence is no longer an abstract entity trapped behind the glass of our screens.
Okay.
It has stepped out into the physical world. It is analyzing the intersections, categorizing the vehicles, and literally turning reality into data.
Which leaves us with a critical question to consider as this technology becomes ubiquitous.
Right. If we accept a paradigm where we rely on tech companies to issue software updates to fix privacy concerns after an infrastructure is already physically embedded in our streets, are we accepting a reality where ethical governance will always be one step behind innovation?
That is the big question.
And if so, what happens when an AI technology becomes so deeply woven into the fabric of a city that a simple software patch can no longer undo the societal consequences?
It is a heavy, completely necessary thought to carry with you on your next commute. So keep paying attention to the infrastructure around you. Notice the quiet technology bolted to the intersections. Keep asking questions about how your data is processed, and above all, stay curious.